As we start our next topic, you see we do skip in Math 105M, but in our previous course, Math 100, we did cover a lot of these topics, and if you need background information, you can go to our other YouTube site, UB Math Zone, without the 105, and that'll take you to the Math 100 items, where these will be gone over in some detail of topics that we're not covering in this course, if you need it for background. So what we're starting here is in topic 6 now of chapter 1. We're going to solve equations and later formulas. But I've set up here a little balance in which we have something on one side and the same amount on the other side, and it's balanced. And we're saying if we, for instance, take something from this side and something the same amount from the other side, it's not the same anymore, but it's still balanced. And if we take a little bit more from this side and a little bit more from that side, as long as it's the same amount, again, it's not what we had originally, but the amounts are the same. And what we're hoping for is now this is a single letter X, and this is equal now, which it was all of these times, to let's say 3. We have a unknown equaled to a known, and that series of steps of taking things away, modifying the equation, again, whatever we do to one side, we did to the other, until we end up with a 1 on this side, a 1x, and then some number. That's solving an equation. And that's what we're going to feature here. So let's raise it up a little bit. And we will start with example 1. Now, it's important to look at what they're asking you to do, because probably in your math lab, in your practice, and quiz me, you'll be doing this type of thing. And it's to determine whether a given equations are equivalent. So here we have 3x equals 15. And then here they're saying 4x equals 20. Well, here we had to figure out that what is x going to be here? In order to get that x by itself, I had to divide this by 3. Divide this by 3, this gave me a 5, doing what we were talking about earlier. So here x is 5. How about here? What will x be here? Well, if we divide this by 4 and this by 4, x is 5. So are these equations equivalent? And the answer is yes. They're kind of asking us to do stuff we may or may not know how to do, but we'll be building up those skills in these examples here. Now in this next one, we have 5x equals 7x. Now if we divide both sides by x, notice the x's will cancel out, and we get 5 equals 7. Well, is that true? And the answer is no. And this set of equations are not equivalent. So no, these are not equivalent equations. And again, they're not building this up in small pieces, but jumping right into something. But let's start with our equations, and we do want you to take notes on this. So I'll write these up here. X minus 4 equals 16. There's a good one to start with. Now, techniques that we may have brought from wherever is to eventually get the x here by itself. So what can I do if I have a negative 4 on this side to make this a 0? And the answer is we're going to add its additive inverse of a negative 4 is a positive 4. We do that to both sides. Remember, that's our rule. Whatever we do to one side, we do to the other. So here, these cancel out and I get 0. So I get x equals 20. And if I put a 20 there, 20 minus 4 is 16. So this checks. Okay, let's do another. And we have 5/7 x. And you'll probably be writing this on the other side of your booklet where you have some room. Now, if we had gone over all of the topics in chapter 1, one of the topics for making something a 1 is multiplying something by something that makes it 1. So what do we multiply this by to make it 1? And we have to do that to both sides of our equation. Well, the answer is it's reciprocal. That is just flipping that over, same sign, but flipping it. So whatever we do to this side, we must do to this side. And notice what happens now. The 5's cancel out, the 7's cancel out, and we just get a 1 there. So this is just x. That's why we use the reciprocal. Now here we have a fraction times a fraction. One is negative, one is positive. So our answer is going to be negative. Negative times a positive gives us a negative. Now 7 will go into there once. 7 will go into there 3 times. 5 will go into there once. 5 will go into there twice. So now we just can't cancel anymore. We multiply our numerators and get a 2. Our denominator, get a 3. X is equal to a negative 3/2. And the steps that we did are called solving an equation. All right, let's do another. And this is our little workspace here. So we have 6x minus 2 times x minus 12 equals x minus 3. Now there is a series of steps that we do when we solve equations. We try to get rid of fractions. We clear grouping symbols. We then get all of our numbers on one side, all of our letters on the other. Then we divide by the number that's with the letter, and then that usually gives us our answer. So let's see what we do here. We have to clear parentheses. So we get 6x. Now as we distribute, we get a negative 2x plus 24 equals x minus 3. Now notice we have two x terms, which we say are like terms. So we're going to group these together, and we get 4x plus 24 equals x minus 3. All right, so this is often where we like to be sort of in the middle of our sequence of solving an equation. And notice I'm trying to be neat, keeping my equal signs under one another. And now we're going to subtract an x here, I should say. Subtract an x there. This will give me 3x. Here they cancel out, I get a 0. And I don't want this on this side, I want the x's alone. So I'm going to subtract now 24. Subtract 24 there. This will make this is 0. And now this will be a negative 27. Okay, again, I'm getting to my next step. Now I have a number and a letter together equal to some number. Well, to get the x by itself here, we're going to divide to get rid of that 3. Because dividing the 3's out, I'm just left with an x. And here, dividing a 3. Now, here's where you need to be careful. And notice this is a positive 3. And on the top, there's a negative 3. So what will be the sign of your answer here? Negative. And 3 times what is 27? Negative 9. Now, if you were to put a negative 9 in each of these places, that would check out. That's your answer. And this series of steps, sort of keeping your equal signs lined up, these are called solving an equation. All right, going on to number 3 here. They're asking us to identify whether something is an identity, a contradiction, or a conditional equation. Well, if you had read the textbook, they go over this in some detail. If you have something like this, 2x plus 2 equals 2x plus 2, this is what we call an identity. If you go to solve it and you subtract out, let's say the 2x from both sides, you then get 2 equals 2. Is that true? Yes. So when you are doing an equation and something like this happens, that you get a true statement, the letters are gone, then this is an identity, and the answer to an identity is that it is all real numbers. And we just sort of double up on a capital R here to indicate all real numbers. Because whatever number you put there, if you put that same number here, that will be a true statement. And that's why this identity, the solution is all real numbers. Now, how about if you had something like this? 2x plus 1 equals 2x plus 2. Now it looks like an equation because it has an equal sign here. But once again, if we subtract out the x's, we end up with 1 equals 2. Is that a true statement? And the answer is no, this is not equal. So when you have something like this, no matter what value you put for x, it's not going to make it true. So for something like this, there is no solution. And this is what we call a contradiction. And then up here where we had x equals a number, That is a conditional equation. If x is that specific value, it makes it true. So here, this is all real numbers. This one is no solution. And this is x will equal a particular value, a single particular value. All right, now let's take a look at these and see what they are. So maybe I could do these down here. Let's see, this is going to be x plus 8 equals 2x plus 6 minus x plus 2. Well, I needed some room, so let's switch up here. So we get x plus 8 equals, I'm going to subtract that x from that, and I get x. Add my 6 and 2 together, 8. Now notice it didn't look like an identity in the beginning, but once we did the things needed to start to solve the equation, collect like terms, we see it is an identity. So the answer to this is all real numbers, and it's an identity. Now when we do this next one, I think there's a little more room here. So we get 4x minus 9 equals 4x minus 4 plus 6. So I group like terms. I get 4x minus 9 equals 4x plus 2. Okay. Again, the 4x's will subtract out, and we get a negative 9 equals 2. Now, is that true? No. So this is a contradiction. There is no solution for this. And then let's do this one. X minus 3 equals 5 minus 2x. Now, one of the things I will be telling you, and we're going to use a lot later in the course, is this concept of what we call transposition, where we take a term from one side of the equation and transpose it to the other side. This is sort of a shortcut. When we do that, and it crosses the equal sign, the term we had changes its sign. So this then becomes a positive 2x. So just transposing that, we can do that mentally. We get a 3x here. Now we're going to take our negative 3 and transpose it to the other side. On this side, it becomes a positive 3, so this becomes an 8. Now to solve it, we're going to divide by the numerical coefficient of our variable, which is 3. And we say our unique solution for this is x equals 8/3. And that would be a conditional equation. This is only true when x is 8/3. Okay, we got a few more there. Now we're going to do some, well, they didn't ask us to solve that last one, but we did anyway. Okay, we're now going to do what is called solving formulas for a particular letter. And let's highlight the letter we're going to look for. This is L. So we have area formula, area equals length times width. How do we solve for L? Well, it's L times W. So this is a factor, and we get rid of factors, or in a sense, a letter coefficient, by dividing. A factor divided by itself will make it 1. So here the w's cancel out and we get L equals A divided by W. Now this one I'll write out because it's a little complicated, and you can write it out with me as we go along. You want to take your notes, are very important in this course. Now the letter we want is H. In fact, I'll make that blue. So here we have a fraction in there. And one of the techniques, and we didn't see it above, but one of the techniques is to multiply every term by its lowest common denominator when there are fractions. So we're going to multiply this term by a 2, which is my lowest common denominator, and this by a 2 as well. Now this is just one term because it's multiplication. So we get rid of this 2 by multiplying it by 2, and it cancels out there. And I now get 2a equals, and I'm going to get rid of the, no, I don't need to. Actually, I'm going to leave it like that. H, if I was going to solve for one of these b's, but they just want me to solve for h. So I don't have to get rid of the parentheses, actually. Now, thinking what we just said, I want to get h by itself. It's h times this. So how do I get rid of this? These are factors. Well, I divide both sides by this. And if you want to put it in the parentheses, that's fine. I'm dividing both sides by what is with the letter H. So this then cancels out, and that is my answer right there. They even put that in parentheses, but no big deal. This division bar is a grouping symbol. That's why we always want to make fraction bars horizontal. Sometimes you see when they're writing it, they'll make it diagonal, but notice here it's nice as well. And you could always go back to look at what we've done. Now let me write this one out. XA plus XB equals C, and we want to solve for the X. Now here we have an X that's in 2 terms. And how do we get the X out of 2 terms? And the answer is we factor it out. We're going to factor out this X. And then we get A plus B there. Now notice, if you take X and multiply it through distribution, you get what we have here. To reverse that, we factor the X out, and we get this. Now what we need to do is get rid of the A plus B, and this is a factor, so we just divide by A plus B, put a division bar there, and get A plus B. And you could put it in parentheses or not, and they don't down there. So here it cancels out. Now, what we will probably be doing, if there is extra time in the class, each lesson is go to some additional exercises, or if you have questions from your math lab, you can actually, we'll bring that up on the computer and work some of those so that you meet your time requirement. But we'll close this one out right now.